We are going to write the equation of motion for a particle moving near the surface of the earth. If the particle is moving near the surface of the earth, how we are going to write the equation of motion using Hamilton's equations. Using Hamilton's equations. Okay. So here let us consider the particle is moving, okay, near the surface of the earth, and we are considering that direction is z. Let us consider it is at the top near the in this z direction. Okay, so we are considering this axis like this. Okay. Now first, to write the equation of motion, as usual we have to consider the Hamilton's equation. Minus Pj dot is equal to dou h by dou qj. Okay, so now the particle is moving along the surface of the near the surface of the earth, maybe along near the y-axis, near the x-axis, near the z-axis. Now here in this case we have to write the Hamilton's equation of motion in three directions: dou x along x, along y, and along z. Okay. Now let us assume that if we are applying any force, always the gravitational force is acting and this force is in this direction. So that F is equal to minus mg, because it is in the opposite direction of the z axis. Okay. So the force acting along the z direction, Fz is equal to, let us assume that, minus mg. Okay. So we can write in terms of potential energy, dou V by dou z is equal to minus mg. Okay. So dou V is equal to mg into dou z. If you can integrate it, you will get the potential energy mgz. So the potential energy is acting, let us assume that, along the z direction. Okay. So now let us consider the kinetic energy, because the particle is moving, okay, near the surface of the earth. It is either its direction is towards x, y, z. In three dimensions it is moving. So it gains the kinetic energy. So in three dimensions you are having the kinetic energy, half mx dot square, half my dot square, plus half mz dot square. Because to solve anything we want Lagrangian function, so we need to write the kinetic energy and potential energy. We know that L is equal to T minus V, and what is the Lagrangian function? We will get half mx dot square plus half my dot square plus half mz dot square minus mgz. Okay, so let it be equation 1. So along x, y, z directions we have considered the Hamilton's equation of motion. In the same way we have to consider the Hamilton's function. Hx is equal to px x dot minus L, hy is equal to py y dot minus L, hz is equal to pz z dot minus L. So if you can solve first along x direction, you will get mx dot square minus half mx dot square minus half my dot square minus half mz dot square plus mgz. Okay. So final equation you will get half mx dot square minus half my dot square minus half mz dot square plus mgz. So we got this hx along x direction. Okay. Now we want px, no? Mx dot already we have derived. So how we got px, I think you understood. That's why I have explained directly. So px is nothing but dou L by dou x dot. So L value, from the L value directly we will get the mx dot. Now if you can substitute this px value and this Hamilton's function in the equation of motion, what you will get? Minus px dot is equal to dou h by dou x. So minus mx dot is equal to dou h by dou x. So if you can see this Hamilton's function, there is no x term along x direction. Okay, x dot, y dot, z dot. So finally we get 0. Okay, d by dt of mx dot. So we got x double dot is equal to 0. In the same way, if we can apply the Hamilton's equation of motion along y direction, we will get hy is equal to, first we can find out py is equal to dou L by dou y dot, and we will get my dot. So therefore we will get hy is equal to my dot square minus half m x dot square minus half m z dot square minus of minus plus mg z. Okay, so if you can substitute these two values, we will get minus my double dot is equal to dou h by dou y. So if you can see this, in this one we don't have any y term. So therefore minus my double dot is equal to 0 and y double dot is equal to 0. Now we are going to apply the Hamilton's equation along z direction. Then what happens is hz is equal to, we will get mz dot square minus half m x dot square minus half m y dot square minus half m z dot square plus mg z. So that is equal to, again we will get half m z dot square minus half m x dot square minus half m y dot square plus mg z. Now we got the hz. Now if you can apply into the equation of motion, then minus pz dot is equal to dou h by dou z. So what is minus pz dot? Minus d by dt of pz is equal to dou h by dou z. So minus d by dt of pz is nothing but m into z dot. From the pz is equal to dou L by dou z dot. From that one we obtained mz dot. So that is equal to, if you can apply this one to the Hamilton's function, here we get 0, 0, 0. Only we are having the z term here. So we will get only mg. So we got m double dot is equal to mg. M cancel. And we got z double dot is equal to g. So here z double dot is nothing but the acceleration due to gravity is equal to acceleration along the z direction is the acceleration due to gravity, and is true. So if we can say that, see, if the particle is moving near the surface of the earth, the particle is moving along z direction, the acceleration due to gravity is always in the opposite direction. So what we have obtained, even it is moving along the z direction, along the surface of the earth, the acceleration along the z direction is the acceleration due to gravity, and this value is true.